Okay. All right, is that okay so far? Yeah. So let's try question 2. Try question 2 by yourself. I think you can do that. Yeah, looking good, right? Yeah. Good, good, good. Yes, everyone is looking good. Try the next one too. Yes. Now this one I don't tell you what is the dy dx dt. You need to write it out yourself. Remember the rate means dt, something dt. Yeah. So good job. Yes, yes, yes. Yes, dy dt is the thing that you want to find. That means you need to have dy dt. Yep. Good. Yep. Good. That means you need dy dx. So how do you find out from dy dx? Okay, what is the question? What is the find? Find the rate of the y. That means the one dy.
dy dt.
Yes, let's write dy dt equal to y. Oh, no, it had to be y on the top. Yes, I will write y first. Yeah. dy dx. Yes, times dx dt. Good. How do you find dy dx? What is the equations that you can change it? Yeah, differentiate. Move it about and differentiate. Oh, okay. Do not move your tube. Okay. So for that question, when you move it about, always remember, do not move the constant away. So you have 2xy equal to 195. When you move the y is equal to 195 on 2x. Leave the 195 on 2 alone. 195 on 2x minus 1. Yeah, do not move the 2 up. Do not do this. Do not do 2x. Don't do that. Do this. And this is how you differentiate. Because constant is a constant. Leave it. Then you are going to have dy dx equal to minus 195 on 2x minus 2. Which is? Yeah. Is that okay? Yes, then you can sub in whatever the x that I told you in there.
I did something wrong.
Oh, your x become minus 2.
Oh, because minus 1.
Yes, because this one should be minus 1 in here. When you bring it down, it becomes 2 again. Without the minus. Remember? Oh, 2x squared is 15. Oh, I think this is not 15 squared times 2. 450. Yep. What do you have?
I have 13 and a 30.
13.
Oh. I didn't put it into the actual thing.
Okay. Okay, one thing I don't want you to write, don't write y dash, because y
Okay.
dash doesn't quite represent dy.
Okay.
Yeah, yes. Yeah, you got the answer? Yeah, very good. Okay, right. Now, Jessica, do you get the answer? For question 3? Yeah, you did. Okay, good. Then we move on to, Ian, you got it? Yeah, let's move on to question 4. Okay. Okay, the 3 centimeter per minute, what is that? What is the rate for that thing? 3 centimeter per minute. The radius, so we are going to write as dr dt equal to 3 centimeter per minute. And what is the question want you to find? The rate of the volume, that means you are looking for dv dt, right? Okay, of course we have 2 terms, dv in here, and then dt in here. What is this one going to be? Has to be dr, because the r is still there. So I'm going to have those. Ooh, my r looks like a v, r is an r, yeah, this one. Right, dv dr, volume, radius. Remember your volume formula? So sphere? Yes. All those need to come back. All your cylinder, cone, and sphere. Those are the 3 main ones. Yeah. Okay, then you can do dv dr, right? So dv dr equal to 4 pi r squared. And the radius is given to you as 5, isn't it? Now we can sub in the 5 into the radius and then sub everything back into this side in here. Looking good? Yeah. Okay.
I was just how you know how when you say rate you put dt at the bottom? Like why?
Why? Oh, the rate means like is according to the time. How much it change?
Okay.
Yes, the rate of change for radius with respect to time. That is what it means by the meaning of rate. Yes.
Oh, okay.
Everyone got the answer? Yep, okay. Right, and the next one, okay, I even need to go back even further, go back to year 10, and or maybe year 9, similar triangle. Okay, so you have a diagram, which, okay, let you read it first. You have a radius of 2 and the height of 5. And now the water is flow from the apex of the cone at the constant rate of 0.2 meter cube per minute. Okay, what is that? How do you translate that one? 0.2 meter cube per minute. Whenever we are talking about meter cube, we are talking about volume. Yes, volume. And then because volume is going to give you meter cube. And per minute, that means dt. So I'm going to write that as dv dt equal to, and the water is going up, right? So the volume is decreasing. Negative.
That's meters
Yep.
cubed.
Yes. Negative means means decreasing.
Why is it?
Meters cubed.
Huh?
Meters cubed.
Meter cube? Oh, meter? Okay, thank you. Meter cube. Okay, because the water is flowing out. So whenever it's flowing out in terms of, because otherwise I look at it, if I see it as a positive, I think the water is increasing. Okay, anything that decreasing, you put in the negative. That will tell you that it's decreasing. Okay, the question is asking you to find, what is the rate that you're finding? represent in the diagram? What is the height represent by? So you have a 5 in here. Yeah, and then it also have a circle on here, and this is your radius, and this is your height. The height in maths most of the time represented by the h. So in here, you are going to the water level dropping. That means dh dt. That's what you're looking for. Okay, dh dt. What are the two things that you are going to write? What do you think the third one that you have? The r dv. Yeah, which one will we be using? dv. Yeah, because we know dv dt. So we are going to use dv. Okay, right. dv dt, no problem. We have the answer for that one. This one, dh dv, doesn't sound so good at all. We can flip it and say dv dh, right? Because volume for a cone. What is the volume of a cone? Volume. Have been a long time.
Does it start with 1 over 3?
Yes, this is a 1 over 3. Yes.
That's all I remember.
Anything pointy, you have 1 over 3. And then, yes, pi r squared h. Right, look at that equation, look at that formula. Not good at all, because I can't do dv dh or dv dr because I have both of them.
Yeah.
What your job is, get rid of one of them. Because you want dv dh, that's what you want. So if you want dv dh, that means I don't want r to be here.
Do you already know the radius?
Oh no, you cannot sub it in, remember?
Oh.
Rules, you are not to sub it in before you differentiate. I can't sub it in. But,
Another equation?
yes, similar triangle, big triangle, small triangle.
Oh.
Yes, the similar triangle come in. So, big triangle, if I write it as a ratio, 2 on 5 equal to radius on height. Yeah, the big one, 2 on 5 equal to r on h. It depends on how you write it. There are lots
Do we
of
have
different.
to give proof?
No, you are not proving. You are just using. Yes. And then you can make r the subject. So r is equal to 2h on 5. Yep. And now you can put in the r into there, and it's going to give you a nice equation with only h now. R equal to 2h on 5 squared times h. And simplify the whole equation, expand, tidy up. So you are going to have 4 pi and 25, 75, 75 h cubed. This is your v. Right, and the reason I put it like this, because this is my constant. We're not going to change anything on it. Here, just leave it alone. Differentiate h to the power of 3. And you are going to have dv dh equal to 4 pi will be 25 h squared. Okay, is that okay so far? Then now is the step where I sub in my number, right? Again, do we have anything to sub in? Yes, we do. The depth of the water is 4 meters, so the h is equal to 4. Sub it in. Yes. So you have 4 pi, and this will be a 16. This will be a 25. Then the very last step, go back to the original that we find out in here. And we have dv dh, but the question 1 dh dv, flip it. Yeah, so it's going to be 25 on 64 pi times by dv dt, which is minus 0.2. Yeah. So your dh dt is going to be a negative. That means the height is decreasing. And one more thing that I forgot to mention. All these questions you need to have a conclusion. Therefore, a statement. Yeah. questions in between?
Sorry, therefore,
Therefore, the, what is the question asking?
the rate of,
The, therefore the water level is dropping at this rate, at this rate. And when you are saying dropping, then you don't have to put in the negative again. Dropping at a positive number because you already mentioned the word dropping is decreasing.
okay.
Yeah.
How did we get the answer from?
From which one?
From here.
Yeah.
How did we get to here?
Oh, I just put everything in the calculator.
Oh, okay.
25 times 0.2 over 64.
Oh, yeah.
So there should be like meters per minute.
Yes. Make sure you have the unit. Meter per minute. Okay, how do you decide the unit? Because you are doing the H. H is meter and time is minute. Meter per minute. That's why when I read it, just remember, just send the one that I have is a meter cube per minute. Meter cube means volume. That's why I know it's dV and dt. Yes, you look at the unit more than the number.
So do we take away the negative from?
Yes, in the conclusion, because you would use the word dropping. Yes, because the water level is dropping at that positive time. Question 6, let's try it. Okay, what is the 2 pi stand for? The
dV/dt.
very good. Yes, dV dt. Yep, equal to 2 pi. Yep, and centimeter cube per minute. Right. And what are you looking for?
dx
Yes, dx, dx, dt.
Oh,
Yep.
yes.
Wait, why would
Yes.
it be dx?
Why it is dx? Because let's look at the second line of the sentence after the formula, where x centimeter is the depth of the water.
Okay,
And then it asks you what is the rate of the depth of the water increasing. So you are looking for dx, dt because you are looking for the rate. So in here that means again I have 2 statements to write. It's going to be dx something, d something dt.
dx dv.
Yes, it have to be dv. It have to be dv. Okay, make sense everything? Then there you go. We have the formula. You can either use the product rules or you can expand the x into the bracket. I'm going to choose to expand x into the bracket. Leave the power 3 outside. 30x squared minus x cubed. Right. Then I'm going to start with expand power 3. This is your dv dx. And then you have the 60x minus 3x squared. And after I differentiate, that means I can put in my number. Yeah, and then the rest of the substitutions. this thing will sometimes come out in a few assessment that you're going to have. Yes. Okay, good. Any questions? No, no. The rate, wait a second, of that is.
The increase.
Yeah. Otherwise, it sounds like something is missing. All right, and the next one, okay, it's a little bit different. That question is really short. Not much information, and too much information at the same time. What is the information we have?
What's that area of the surface?
Hmm?
What's the surface area of the sphere?
Yeah.
Formula?
You differentiate the volume, you get the surface area.
Oh, really?
You did?
I'll have to go back and
Now I can tell you that. Before this, I can say that. 4 on 3 pi r cube, and the surface area equal to 4 pi r squared. Yeah. Which is the differentiation of the volume. Really neat. Extremely neat.
How does that work?
Okay, so far what we have is the surface area is increased at that rate. That means that will be d. What do you want to call your surface area? You want to call it as an S or the A? I'm not going to use SA. S. Okay, let's call it as a ds in here. The S dt is equal to 3 pi. Yep, that's the first piece of information. And now, at what rate the volume? You are looking for dV
DT.
dt. Good. You are looking for dV dt. That's what I'm looking for. dV dt equal to dV d something dt.
DVDS.
dVds. Yes, but dVds. How do you get v in terms of x? That will be a trouble, right? But the information we have is really the SDT. So let's leave it there and see what do we have. Right, now if you look at this one in here, the SDT. How do I get the DSDT? The SDT, I can think of it as we have the S, let's call it as S, not SA. S. What I can get is that I can get the SDR. The RDT, that will give me the SDT, the SDR. Okay, let's try to work on that part. Okay, so if I have the SDR, will equal to the SD something and then the something dt, and in the R, no, not dt, the SDR, and the something is going to be the SD, what is that? dt, yes, thank you. And then the R dt, right? Okay. The SDR, something we can find. Let's find it. Okay, the SDR equal to 8 pi r. And you know the R, right? Yes, I think we do. They do tell us. I differentiate, now I can put it in. So it's going to be 16 pi. And if I put all the information into here, that will give me the SDR is 16 pi, the SDT equal to 3 pi, and dt dr. And that means I'm going to have 8 equal to dt dr. 8 divided over?
By
No. No, it doesn't. No. That was so wrong. Yeah. Okay.
Wait.
Yes, we do.
Oh, I do.
We do. dV over the R and dr dt, because I know dr dt. Okay, let's rearrange it. Dr dt equal to 3 on 16, right? Mm. Yep. So dr dt, I know it. Now I can use dv dr. Yeah. So you have your dv dr equal to 4 pi r squared, and is equal to 4. Oh, I haven't sub in the number. R is 2. 2 times 4 is, no, this would be 16. Yeah. Times it by, what's it, 3 on 16? And the volume will be centimeter cube per second, minute, second, yeah. The unit are given in here. Yeah. Your big job is just play with that number that you have. So now, yeah. Yeah. Okay, then we move on to the next page, which is the next type of equation. Okay, that question is supposed to go on to the first one. Okay, so whatever you are doing at the moment is the instantaneous rate of change. That means the rate of change at that particular moment when r equal to 2 in here. Okay, and what you have on question 8a actually is the average rate of change. Okay, let's read that questions and think of it as a really logical. Okay, don't think of it any of these. Question 8, it should be on the question, the earlier questions. Let's think of it really logically, and what should the answer be if you think of it? My neighbor must have party. Oh yeah. Yeah, there's more car outside than usual. Okay, it goes from in here is tell you that the metal is expanding at 0.05 centimeter per second. So if at the moment I have everything empty, I got not much information, you have no, it is a square. When it is a square, I can start labeling things. What do you want to call this sign? L, yes, why not? Yeah, so those are the L. And that means you can write it as 0.05, that means it's going to be dl dt, right? If you want to write it, yeah. So I can say dl dt is equal to 0.05 centimeter per second. Okay, as what I told you on the question A, I said, do not even think about all of this. So the average rate of change of its area as the length increased from 3 centimeter to 3.1 centimeter. Instead from 3 centimeter, it goes to 3.1. How long does it take? 2 seconds. It takes 2 seconds from here to there. Because 1 second you go 3.05, then 3.1, 2 seconds. And then what will happen to the, if you have 2 seconds, then what are you going to do next? What is the rate of change of the area? What's the area? What's the area that you start with? It's going to be 3 times 3, right? It's going to be 9, yep. So the area of the start is going to be 9. And then the area of the end is going to be 3.1 square, whatever that number is. And the average rate of change, that means how much does it change? The average rate of change. going to be whatever you have n minus the beginning over 2 seconds because it takes 2 seconds to change it. And that's it, that's your average rate of change. When you are looking for the average, remember last week we are talking about the total distance traveled, the average speed. So you always find out the total and then minusing it and then do the divisions. Yeah, and this one is going to be similar. Right, and that's it. That's what you're going to get. What do you have?
0.35.
0.305? Yeah. Because it's area, centimeters squared per second? Second, yes, I know second. Right. And then the part B is what we have been working on. Find the instantaneous rate of change when the length is 3.1. So that means you are looking for dA dt. Yes, you are looking for dA dt. The area is going to be area formula equal to L squared. Then you're able to find out dA dL. Right? Yes. And then, oh, I forgot to write this. dA something, d something dt. And the something has to be dL, right? dA dL, you know it. dL dt, you know it too. That is the difference between instantaneous rate of change and average rate of change. A big party is going on. Okay, and question 9 is going to be really similar to the cone that we have. I think it's question 5. Can I let you try that one at home? Yeah. Any question, we discuss it next week? Yeah. Now I'm going to go ask you to move on to question 10. There's another type. This next type you're going to fix it. Right. And most of the time for this type of question, in question 10, I give you a diagram. Okay? I want you to kind of like snapshot it, put it in your head, because you are not going to see that diagram in your questions that you are going to get. Okay. So if you're giving you, read the questions and that is the diagram, you have to draw it up yourself all the time. Yep. You have a ladder that is 10 meters long, and then you have, knowing that the speed of the base is going to move out. Yeah. So you have a wall, you have a ladder, it's going this way, and you don't have any number. So your job is to create all the pronouns, create your own equations. That's called problem solving. So I just keep it as an axis. This is my x-axis. I will call this as an x in here. If I call this as an x, the ladder is moving out that way. Okay, you can imagine that it's moving out this way. So the ladder is moving out that way, and then you have it as dx dt. The dx dt given to you as 4 meters per second. So at the moment, I'm treating it when the x is moving upward as a positive number. Okay, so and now I'm having this as an x, and then I call this as a just a normal equation or number plane. This is going to be a 0y. So that means this thing is going to go down this way, and you are trying to find dy dt. As what we always do, dy dt is always equal to dy, d something, dt. Here is quite obvious, has to be dx in here. Right. Having those terms, now the next thing is, I don't even have an equation, right? Let's create the equation. Something I did not write down yet. What is the things that I forgot to write down?
The length of the
Yes, the length of the ladder, which is a 10 in here. If you have that as a 10, then the next step is going to look pretty good. Because I know this is an x, there's a y. Your famous Pythagoras theorem is still coming back. Yep, x squared, y squared equal to 10 squared, which is 100. And our job, you want to find dy dx. So that means make y the subject, move everything to the other side. Okay, in here I can keep it as a positive because y always have to be positive. I can just straight away say that y is greater than 0. I don't have to worry about the negative side of it. And you do normal differentiations as you always do. Then you're able to find out the dy dx. And the rest of the substitutions is going to follow on. So the idea is create your own equations by using it as an unknown in here x and an unknown on the other side too. Make sense? Everything?
But do we
When do we start in the number? After you differentiate.
6. So we sub 6 into here.
Okay, what's that slide there? When the lower end is
Here.
from the wall. Yes. Yeah. Jessica, did I send you inductions?
No, just random change in the revision.
Oh, I really forgot to. Okay, I'm sending you now the inductions.
Well, let's have a question. When we give the final reasoning, do we have to say do we have to give like negative? Or can we just say if it draws closer to the ground, it's okay to
No, you don't have to say that. You mean the final conclusion statement, right? No, you don't have to write the negative. Yeah. As long as your statement having something to do, knowing that this is coming down.
Okay.
Yeah. Okay, the next question I'm going to try actually is the last questions. Not the one after this, but the really last one. Yeah.
Shadow.
Doesn't look too friendly.
Isn't the shadow same rate as him?
Sorry?
Wouldn't the shadow be moving at the same rate as the man?
No, because as you walk further away.
Yeah, the
it's-
angle. The angle, the
But like like when they play all his. Okay.
Yeah.
Okay. Then it just slowly increases.
Tonight, when you are walking, you will be looking at those shadows. Your shadow increasing faster.
It increases, yeah.
So,
Okay, you have a man. You have him walking away from the lamppost, and then which is 5 meters high. Okay, let's start with that. Lamppost, man, walking, shadow. This is a man. This is a lamppost. This is a man. The man is walking. What do you call this as a distance from the man? So first one, you can label it anything that you like. There is no one way of labeling. Okay, if I call it as an x, that means I will have the x dt. The weight. How fast is the man walking? 1.5.
And then
The
his
man
guy
is
is
1.8. Yes,
It's not
it's not
that
1. Yeah, not that short.
he's tall.
Yeah. From a short man to a tall man. Okay. Right. Okay, this question probably you can find in every single textbook, so make sure you understand it. Right. Okay, the first thing, find the speed at which the tip of the shadow is moving. So that means you are looking for this thing. Call it a y.
dy.
Yeah, dy. Yeah, dy dt. So this is your y, the whole thing, the tip of the shadow.
But if it's slowly increasing.
Sorry?
Oh, no.
Yep, let's see dy dt. That means you have dy d something dt. And what is that something has to be? The x, yes. Very likely, most likely to be there. Okay, right.
Equation.
Equations. How is that going? How are we going to magic it up? Triangle. Two triangle.
Similar.
Yes. Similar triangle again. Right. We have two triangle in a similar triangle all the time. 5 over 1.8. This over that is equal to 5 is the long one over this one, short one, which is y minus x. Yeah. Big over this is going to be this one over that one.
Oh,
Yeah. Yeah. Either way, you can write this over that or yeah. 1.8. I can't write 1.8. Yes.
wait, what?
I use this
Oh,
over that
that is
equal
equal to
to
the whole thing.
the big one over the small one. Yeah. Rearrange it, simplifying it. If you want to 5 over 1.8, does it give you a good number? I think it should. 5 over 1.8. No, ooh, not a nice number. But you can write as a fractions if you want to. Or you can leave it like it is. We can leave it. So you have 5y minus 5x equal to 1.8y. Move it at 1.5 minus 1.8 is 3.2, right?
Yes.
So y equal to 5 over 3.2x. Is 5 over 3.2 good number?
1.5625.
Oh, no. I will leave it as leave it like this. Or if you calculator will be 25.16x. Then you can do dy dx, right?
Yeah.
Yeah, we can. That's a simple dy dx. And then you know your dx dt, and you can put it all in. That is the first one.
What's the first one?
Yep. The second one is really straightforward, don't worry. Yeah, the equation is the one that you need to realize that, okay,
Did you get the answer?
do you get the answer?
Yes, I did. It's rounded.
What do you have? These
What
one
did you get?
times the 5?
Not the answer.
What did you have? Let me see. 5 on, yeah, you have it. 5 on 3.2 times 1.5. We put 0.
Oh, okay.
Mm.
Okay.
Yeah. Okay. And the second part is asking you to find the length of the shadow, which is, what is it? Here.
Y minus x.
Yeah, y minus x. Y minus x. The length, the rate of the length of the shadow. That means you are looking for d y minus x dt. That sounds so untrue. That sounds so weird, but it's okay. Yeah. And it's just like normal equation algebra, you can just break it up.
Just do dy over.
Yeah, dy dt minus dx dt. And you know both of the value already. Just put them in and then you will find it out. Okay, I'm looking at the question 3. Now there is a wall coming up. Okay, the man is walking toward the wall, and the wall is also 5 meters. Okay. And then the man, the shadow, you can imagine the shadow is going to climb up something like this. This is the man. Yeah. As you get closer, can you imagine that?
Is the wall 5
Yep,
meters?
5
Or is it
meter from the
5
man.
meters from the lamp?
Yeah, 5 meters from the lamppost. Yes. Yeah.
Oh, okay.
So it's like very close to the wall, my shadow is going to climb up the wall. That's what you know. And the shadow is going to come up, something like this. The man is still 1.8, it doesn't go any taller. Right. Again, the main idea for us is to, okay, and the question is asking you how fast does it go up? Okay, so far we have all the, this is your, we call this as an X, right? We call this as a Y so far. And now we wanted to find how fast the shadow grows. So that means X, Y, maybe call it a Z. That's your questions. If this is my Z. Does it make sense? So far. Right, Z dt is going to be dz d something, d something dt. Okay, let's see what we can do. Create equation again. Not like the other one is like
It is similar thing again. Was it-
similar.
also,
Yes, similar triangle. We need to create one more line. Make it a similar triangle.
Oh.
Yes. So because we know this is a H, this is a Z, this is a Z. That means this one in here is going to be 1.8 minus Z. Yeah, because this is a Z, and this one become 5 minus Z. So I need you to redo these questions in the next 2 days. Make sure you still understand what we are going on. It sounds very logical, but it's just that doesn't click in your head. It's that it doesn't come out. And now you can have the triangle. We are going to have 5 minus Z over this one over that big one, which is a 5. This one, 1.8 minus Z over this one, which is, what is that, y minus x. Over y minus x. Oh, okay, but the good thing is we know the y. Y is 5. So it's going to be 5 minus x. Then you have
The same should be the same instead.
Yeah, it's good.
Okay.
Yeah, it should be the same. 5 minus z on 1.89 minus.
Minus.
Yes. And then that'd be y. Y is, what is your y? Y is that one.
The whole
Y,
thing.
okay, over, yes, and then you can sub in the y as a 5. Yes, that's totally fine. Then you do the same thing, and now you know this one has to be dx, isn't it? Because we already used the x. Yep, make the equations, differentiate the equations, sub in the number, find out the value. Okay, let me write the instructions.
Thank you. I don't know.
Oh, yeah, making it that way. Okay, can you give me the equation that you have, Gabby?
For
Yeah, for the Z thing, for the similar triangle.
x equals
Oh, no, the one before, on the very first step.
5 minus z over 5 equals 1.8 minus z over 5 minus x.
Okay, right, you're making X a subject, right?
Yeah.
I think you don't have to. Okay, let's expand this. So if you have that, so you are going to have it as 525. Did you expand it? No, you write it like this.
did it. Yeah, and then I
5 and then 1.8 minus Z.
divided it.
Oh, you divided it. I just wonder, is there any other way to? Not really, isn't it? Yeah, I think, yeah. You have to do it that way.
Wait, where do I sub? Oh wait.
That is your, that's your X. That is your X. You have the X is Z. Okay, so in that case, we need to sub it into, what is the original equation here? Yeah, if you know that X is that, you find out the Z. Oh.
My bad.
Yeah.
Okay.
Hmm.
So then this differentiation is not.
No, it does. So, yeah, so because right now you got no Z to sub in. So you put in the X as 4, and then you make Z the subject, find out what Z is, yeah, and then sub in the Z in here. Yeah.
Okay.
Added that to do this,
This one?
and do I differentiate z?
Yes.
And then just
Equations. You have 5. And this one is
and
xz.
then
Yes, zx. And then you have the
negative.
yes. I think Gabby, if you differentiate this one, not differentiate, expand this term, it's going to give you, I wish you get a really simple term.
Oh.
If you expand it. So you are going to have 25 minus x, 5x minus 5z plus xz equal to 1.8.
9.
9, thank you, minus 5z.
Which is
This one is gone, right?
with the x.
And 25 plus 9 is 35.
Yeah. Is that 30?
Oh.
25 minus 9.
Oh.
60, yeah.
Wait,
60.
no. So, what is
Uh,
that?
It's
It's
16.
16
It
here.
is. 16 minus 5x equal plus by xz, right? Equal to 0. So if you make, yeah, x the subject, you can factorize the x out. So you have 5x minus xz equal to 16 here. And then x equal to 16 over 5 minus z. And then you can have, yeah, you should get the same equation. Do you have the same one? Your x.
I thought
I got it the same except the opposite way around.
The other way around? Okay, did I did something wrong?
I
So,
would have the same thing wrong.
5x minus xz, take the x out.
No, I got the same answer.
Which one?
And
This one?
probably
what did I do wrong?
Yeah, then it's easy for you to do the x dz. Or I can even do this. Yeah, that is good enough. Or else you can switch it around. If you want to switch it around, 5 minus z equal to 16 on x, right? So z is equal to 5 minus 16 on x. So that means you can do dz dx. Equal to, yeah, bring it up. And that would be so easy to differentiate.
yeah.
Let me see it.
Oh, yes.
So,
Wait. Should we?
This one is a 9. Right? I think you written it as a 4.
oh. Wait. No, because I did 5 minus. Oh,
No!
oh, I read my writing out wrong. Great.
What are we supposed to sub in?
What are we supposed to sub in? You're supposed to sub in your x equal to 4. Because the person is 4 meter from the lamppost. So that means your x actually is 4.
Okay.
Yes. Differentiate before you sub in, okay?
Okay, yes.
Make sure you sub in. Yes, then you can do the z. Yep, that's right.
Wait, would you sub in?
You sub in x equal to 4
Okay.
because increasing at 4 meter from the lamppost. That means this distance for the lamp is 4. Oh, you will not have 5 when you differentiate the 5 from. 5 is a constant.
right.
Yes.
Oops.
Okay, let's get rid of that 4.
These
And then let's differentiate the
Yeah.
Yes. Yes. And now negative times yeah, then that will be right.
Okay, no,
Yes. Yeah, we got it?
Yeah.
Yeah.
The same as. Okay. It's alright.
After a long way.
I'm gonna forget how to do this.
Yeah, maybe you do in 2 days time. Make sure you do it either tomorrow or the day after, and then repeat it again and again and again for a few times.
I'm pretty sure if I do this tonight, I would know how to do it.
Yeah, there's something that it really easy to forget. It's very logical when you look at it because the reason is why is you find easy is that you were not able to put in what is your x, what is your y. Yeah, so just make sure you read the question, understand why you put an x there, why you put a y there.
There's some,
Yeah.
why is, what do you do this time?
Oh, tan inverse. Oh, you haven't. That means the angle tan theta is
It's-
equal to.
it's the free, is the. Yeah.
Yes, yes, yes. So what it means is this is the angle theta, this is 3 on 4. So that means tan theta equal to 3 on 4. That means theta equal to tan inverse of 3 on 4. Just like in the calculator. It
And,
means this. What you do is draw up this one.
and so when it means it's semi-vertical of the vessel, so when it's down, it's like.
This one.
So
Semi
it's the one in here.
Yeah,
Like,
because your vessel is look like this. Oh, this one.
okay.
Yeah.
And then that will help you with like the depth, the
The
sides.
triangle, similar triangle.
Okay.
Yes, yes.
Okay.
Okay, try it, those 2 questions.
Try it now.
Okay, right. And I'm going to quickly explain inductions. We got only 4 minutes or 3. Okay, so we might not have time. Just introduce you. Doesn't matter. We can continue on next time. Right. Inductions. You have what your idea is to prove that statement. Okay. In order to prove that statement, your job is to prove the really first case is true. Okay. The first case in here most of the time, or almost 100%, is going to be n equal to 1. So the first statement you are going to say is like prove true for n equal to 1. Okay, then you prove it on the left hand side, you write it on the right hand side. In the question you have in here is the left hand side is a bunch of things, isn't it? So what you do is I put n equal to 1 into the really last term. So you are going to have start with left hand side. You are going to have 4 to the power 1 minus 1, which is equal to 4 to the power 0, which is going to be 1, isn't it? And then you do it with the right hand side. So right hand side, again you write the equation out and then you sub in the equation. So you are going to have a third, and then 4 to the power 1, and then minus 1. So if you sub in a third times 3, which is going to be 1. And therefore, left equal to right, and true for n equal to 1. This is the first statement you are going to write.
Why can we disregard the previous terms, like the 1 plus?
Oh no, you are not disregard it. So what it says is that if you only have one term, when n equal to 1, if you have, because all of those terms actually is created by sub in n equal to 1. Okay, 1 plus 4 plus 16 plus da da da. Okay, this term is created by put n equal to 1. This term by sorry?
Oh yeah.
Yeah, this term created by n equal to 2. So if you have only one term, that means when n is 1, that means all this doesn't exist. You only have one
Okay,
term.
that makes much more sense.
Yeah.
The teacher never explained it, so I was like, can we just do that? I was so confused.
N equal to 1 means you only have one term.
Okay, that
Yeah.
makes so
There's
much
2
more
terms,
sense.
you'll need to write 1 plus 4.
Yeah, that is 2 term. N equal to 2. That means you have 2 of them. You add them up.
Oh, okay. So
Yes.
that makes some. Okay.
Yeah, not ignore the rest of the. So it is still there, except we only consider one term. Okay? Then what you are going to do, the next step is that we are going to assume it is true when n equal to k. So the idea is like, if I prove the first term, and somewhere in the middle I say, okay, if this is a true, then I prove the term after that. And if I'm able to prove this term after that is true, That means if this one is true, that means I'm already proving that the one after it has to be true. So it keep repeat itself. If this is true, I prove this one is true. That means if this is true again, now if this one becomes the blue, that means the one after that have to be true if you prove it, right? So what you do is that you kind of pair them up. So they always call it as a domino effect. So if this is true, you assume it is true, you're able to prove this is true. If this is true, that means you're able to prove the one after that is true.
Yeah.
So that is why it keeps repeating. And that is how not the whole thing has to be true. It's okay. It's okay. So we are going to write out the whole process next time when you come back from the break. Yeah.
This is true.
Yeah, if this is
Yeah.
true,
Yes.
okay, if you assume this one is true,
It's true. That
you
means that
prove this one is true. If this one is true,
After
that means
you assume the first.
That
yeah,
means this
if
one's
you
true.
that means yeah, this one now it replaces the one before.
Oh.
Yeah, that means the one after is true because you already proved if you stand in front of me, you are true, I'm true. If I'm true,
Okay.
yeah.
So assuming that you're true
Mm.
and you prove that he's
Yeah.
true, then
Yeah.
the next one will be true, assuming that you're true.
Yes. And then what happened is that we prove the first one is true. That means the second one we prove it is true.
True.
So you,
That means the third one has to be true because
so this is true and this is true.
mm,
And so when you prove this is true, this one becomes this one.
mm,
And then the next one is
Yeah,
true.
yeah.
Oh, what if the first one's not true? Oh, so
Ah,
the first one
but
is
it's
oh.
true.
Next one's not
Oh,
true, then
okay.
the rest
Yeah.
is true.
Well, they
Yes.
have to give you a question when it's not true.
no. Yes,
Okay.
yes, you can. Now you can. Yes,
And then
before
so,
this is done.
so it's just one
Yeah.
black and then you'll just say it's not.
Okay, we'll see you next week. Not next week, 2 weeks from here. Yep, have a good break and do not stop working, okay?